We're going to jump straight into that dynamic NAT lab, and here you can see I've taken the previous command off. Of course, getting rid of static NAT wasn't terribly complicated since there was just one line, and we were using the exact same addresses. I left IPNAT inside and IPNAT outside on, so now we can go straight to the second biggest error that people make in NAT configurations. And seriously, none of this is complicated. IPNAT inside, IPNAT outside, it's just remembering it. What you want to watch here is your ACL. Because with dynamic NAT, you need to write an access control list that when addresses are permitted by that list, they are permitted to have their addresses translated by NAT. If they're not, and remember we got that huge implicit deny at the bottom, if they're not allowed to, then of course they can't go out and use NAT. That's a big troubleshooting spot. You want to watch that because what tends to happen is a certain network gets allowed by NAT and you leave, and 6 months later they add other hosts, and a guy who read a book once but didn't take my class puts IPNAT inside on that particular Ethernet interface, and then they can't figure out why those people can't get their addresses translated. It's because they didn't match the ACL. So let's go ahead and get that ACL knocked out first. Let's do access list 5. Get tired of doing 1 all the time. We're going to do a permit, and of course what are we matching on with a standard ACL? Source IP address. So we are going to go with 10.110 here. That's our wild card. We're not going to log it. And that's it, because of course we have the implicit deny. It's going to deny everything else. Pop quiz, why would I deny that with an explicit deny statement? There's a clue on the screen right now. Why would I put an explicit deny statement, deny any, when I know I have the implicit one? Because I would want to log them. That's what I could do then. So let's go ahead and start that NAT configuration. We're going to start with IPNAT, go to inside and source. So far, pretty much looking like what we did before, but this is where it changes, and that's where you want to be able to spot this number in the middle of a NAT config, because somebody will point to it and say, you know, what's this list 5? What's it talking about? Well, it's talking about the access list we just wrote, because when you're using dynamic NAT, this is the way we need to go. We need to go with list here, then the name of it or the number of it. And we've got a couple of choices here, but since we're using dynamic NAT, which involves a pool of addresses, we're going to use pool, and then you've got to give it a name. And I know that we haven't created it yet. We're going to do that now, and of course the name has to match, and it doesn't matter if you create the pool first and then use this command. Doesn't matter. It's like login and password on the VTY lines. Doesn't matter the order in which you create them, as long as you create them both. I think we've got some overload, but we're not going to use that for the pool. And there we go. So now we've got to create that pool, and that is begun with IPNAT pool. We're going to call it NAT pool, of course. Just keep it clean and professional when you name your pools. Word to the wise, seriously, never use a password or an ACL name that you would be embarrassed to read aloud in a meeting. You'd be surprised how often that happens. Anyway, so we've got IPNAT pool, NAT pool. And we've got the start IP address. Note that we are not entering every single individual address that we are putting in the pool. This is a very important point, because I've had plenty of people over the years say, well, you know, why are you only putting 2 addresses in here? And it's like, well, it's because it's the start and the end of the range. So when I put in IPNAT pool, NAT pool 210.111, 210.115, the actual addresses that are in the pool are 1, 2, 3, 4, and 5. So let's go with that. Pause for just a moment there. Let's see what our next choices are. Net mask and prefix length. And note that we do not have a CR here, so we've got to do one or the other. I'm a traditionalist, so I'll use net mask, and we're going to have this mask. And that's it. We got that command on the screen. Didn't think we'd make that. But we've got our pool created. We've got our ACL written, we've got our source list done, everything's done there, and we know we've got the inside and outside interfaces taken care of. So the best thing to do is to go ahead and do another extended ping. Don't go too fast. There you go. I'm always waiting for extended commands. And that's where we're going to put 10.113. And then the rest of those we can just tap right through. Ping goes right through. And there's your translation, 210.111, the first address out of the pool, to 10.113. And that's really it. We can do a show IP NAT stat. I just like saying that. And this is a great one for dynamic ones as well. And you can see I did some labs before this with NAT. So we had 2 misses, but 38 hits. And we've got 1 active translation, even shows you how many are static and dynamic. This is a great command. Again, this is show IP NAT statistics. I just call it NAT stat, but it's show IP NAT statistics. Shows you your outside interfaces, your inside interfaces, your expired translations, dynamic mappings. It's got your pool right here as well, which is great. It even shows you the name, what the mask is, start and end, how many addresses you have in the pool, and how many are currently allocated. That's a really great command to get any troubleshooting started. And that is it for our lab right there. There is one thing, though, as far as dynamic NAT goes, that I want to talk about. We talked about one real-world troubleshooting issue earlier with adding hosts later, but they're on another subnet, and you don't change the ACL. Well, you would change the ACL because you'd know to do that, but someone who hasn't taken my class might not know that, right? So, they just put IP NAT Insight on the Ethernet interface facing those new hosts. Well, that's not going to be enough. They got to be added to the ACL. But let me show you the example in the book. And what I did here, actually, is just put a couple of hosts on the network. And we've got our NAT pool, etc. And what I wanted to stress here is that here in the lab book, and I'll add a drawing to that too, we had 4 addresses in the pool, but only 3 hosts because I was using the previous one. Let me bring that back up. There we go. So if we have 3 hosts here and we have 4 addresses in the pool, if we could configure dynamic NAT with this setup, we'd be in good shape, right? I mean, literally we could never have an empty pool. But what can happen is something like this. Again, it happens after you leave. Because as I said, we had 4 addresses in the NAT pool and only 3 hosts that need translation. Hey, no problem. But here's a little phrase you're going to hear over and over in networking: planning for future growth. Because let's say that you were called to the client site that had the very topology that we were just talking about. And they were fine with those 3 hosts having access to the internet. So you write the config we talked about in static or dynamic, and you leave the site, and everything's fine. Then someone comes in a couple of months later and adds hosts to the same subnet. So this isn't the same issue we were talking about before, where the router, the ACL wasn't changed. If you're adding hosts to the same ACL, then the same subnet, then the ACL really isn't the issue. But what would be the issue here, as I'm sure you already see, is that now we got 6 hosts, but we got 4 IP addresses in the pool. And we know that's not going to be good. Because with that config, any of our hosts on the 10550/24 network could have its address translated to a routable address from that pool. That wouldn't be the problem. And that was fine when we had only 3 hosts. We had plenty of addresses. But now we have an overcrowded pool area, and overcrowded pool areas are never any fun. Whether it's a real swimming pool or whether it's a NAT pool. Because your eventual phone call from the client is going to be something like this. Everything was fine, and they'll probably leave the part about adding some PCs out because, we're part detective and part mind reader. We have to know these things. But, we got some people that can get on the net sometimes and other people can't. Then it's, we never know who can and who can't. They're probably not going to mention the part about we added some PCs. You know what you're always asking your client in this situation? This little troubleshooting bonus lecture here. One thing about troubleshooting, of course, you always start at the physical layer. The next thing about troubleshooting is asking the client and continuing to ask until you get an answer, what has changed since this stopped working? Because something had to. The magic elves didn't come down, throw something in the router and it just automatically stopped working. Something happened. And in this case, it would be that they've got too many hosts for their pool. Because what happens is the first 4 hosts to request a routable address are going to get one, and the others are just out of luck. So in that case, you've got a couple choices. You can add more routable addresses to the pool, or you could configure what we call port address translation. Let's go ahead and talk about that for a minute, and then we'll do a lab on it at the end here. PAT is a wonderful solution. because this allows for a bunch of hosts, a technical term I know, a bunch of hosts to be added to that subnet in the future without adding more routable addresses to the pool. Even better, you don't have to use an address pool. You only need one routable address for PAT, and it's a routable address that's already in use. So you're hearing all this and you're thinking, this sounds like what I want to use, and it probably is. Well, let's talk about PAT for just a moment. It's much more commonly referred to simply as overloading. And you saw when we were on the live equipment, you probably saw the word overload a couple of times in the choices and in the options. We didn't go that far yet, but we're going to. Because what happens is the private address is translated to a single public address. So everybody's getting their inside addresses, their private addresses, translated to the same IP address. And you're thinking, wow, that's fantastic. How the heck does that work? Well, what happens is a random port number is used for each host. So it allows the same IP address to support multiple hosts. And the router is going to keep the connections separate by using the same translation table, and you'll see the same IP address in that translation table up and down the line, but you'll see different port numbers. Even better, port address translation is simple to configure. Instead of referring to a NAT pool with the IPNAT inside source command, we simply refer to the outside interface, and I believe we saw that option. I don't know if it'll still be here. That's when we did our IP source. Yep, let's come back to that instead of finding it in the middle of all that. Instead of using IPNAT inside and then referring to a pool, you just refer to the outside interface name followed by the word overload, and that's it. And this is essentially what happens right here. We have three source addresses, three inside private addresses, 10.5.5.2, 3, and I've got 10.5.5.3 again. I'll change that to 4. Then when they come through and they're being translated to 210.111, but different port numbers. And obviously these port numbers are not going to be from the well-known port number range. You're not going to see 23 or 53 or 80 here. That would not be wise. But the NAT translation table, again, is going to keep track of the port number mappings. So as packets come in with 210.111 as the destination, the router simply translates them back to the appropriate inside IP address. And again, as with both versions of NAT, the entire process is transparent to the host. So this is really sweet because not only does it allow us to overload a single IP address, we can overload an address we're already using on the serial 0 interface. You can also overload addresses from a pool. I really haven't done that often in the field because if you're overloading to me, just go ahead and overload that one IP address. But if you want to create a pool and overload the addresses in it, there was that overload option that we saw for the pool. So what I'm going to do right now is stop and clear the router of all the NAT commands except IPNAT inside and IPNAT outside, and we'll take a look at port address translation when we come back for the last video. See you there.